Hello everyone, welcome to Dakshana E classroom program. I hope everyone did their best in FST 24 and your final exam is also very near. So I wish you all the very best and try your best. Keep on filtering your errors, mistakes that you are doing, like identify in every exam and remove them. So with that, let me just talk about the solution of FST 24 paper 1 part physics. So question number 1, a small solid ball of density rho naught is held inside at point A in a closed cubical vessel container of side L as shown in figure, actually filled with an ideal liquid of density rho naught 4 rho naught. Now if the containers start moving with a constant acceleration a naught horizontally and the ball is released from point A simultaneously, it has been observed that the ball hit the point Q after some time t naught. Point PQ, A, PQ, R and S all are lying in the same plane, then choose the correct options. So here this is one ball whose density of the ball is rho naught. This is completely filled with liquid of density 4 rho naught. And this system ball is being held here at point A and this distance is also L by 2 and that is also L by 2 and PQRS so unmarked. This is actually like, and now this system is given acceleration a naught and at same time simultaneously this ball is released from here and it has been observed that the ball is striking finally at some time t naught point Q. Now you are asked to find the correct statement like options. So for the ball to hit the top of the container at end Q, a naught is equal to, so let's see. So what is happening, like what are the forces acting? One is mg, and if I look at it, this ball by sitting in this frame, then there will be pseudo force that is also ma, if m is the mass of ball so that I can write if v is the volume of the ball then mass of the ball can be expressed as v rho naught into v. Okay, so now the total force acting on this ball is mg downward and ma this way, actually like this is the force. So now I can write the g effective will be equal to, actually like you can write g like this. If I am taking this is a bar, then this is g bar plus a bar, but remember that this I am taking a bar, so that will be coming out to be basically minus of g j cap and minus this value of a will be equal to a naught, so you can write a naught into I cap. This will be your g effective. Then buoyancy force acting is equal to what? Minus of v, volume of the ball, rho liquid into g effective, because it acts exactly opposite of the force. If mg is acting downward, then it acts, buoyancy force is exactly acting upward or opposite of that. So this implies the buoyancy force is given by minus v rho l is 4 rho naught into g effect is minus g j cap minus a naught I cap, and that comes out to be 4 rho naught into v g j cap plus a naught I cap. So the total force acting on the ball, I can write F net, this is equal to what? 4 rho naught v g j cap a naught I cap, and these two forces, that is minus m a naught, m, let me write it, rho naught into v into a naught I cap minus rho naught into v into g j cap, and this comes out to be 3 rho naught v into g j cap plus 3 rho naught into v into g into sorry, not g, it's a naught I cap. So these are the total force. So now based on that I can write acceleration in x direction is equal to what? Fx divided by m, that is equal to 3 rho naught v a naught divided by mass, this is rho naught into v, so that is equal to 3 a naught. This is the acceleration of ball in x direction, correct? And we want the ball to be hitting exactly at point Q, so the motion should be along this straight line, that is AQ, is it? So based on that I can write tan theta will be equal to what? This is AY divided by AX, and by same way I can write AY is equal to what? 3G divided by AX is 3A naught, and that should be equal to what? This should be equal to AY is L by 2 and AX is L, I'm like displacement, this is L divided by L by 2 in y direction divided by L, so this is coming out to be 1 by 2, and this implying A naught should be equal to 2g. So we got the value of A naught, and acceleration we already have. Ax is equal to 3a naught, so Ax is equal to 3a naught and A naught is equal to 2g, so it means it's 6g. And now I can write x is equal to what? Half into Ax into t square. So we can get the time, how much it will be taking exactly. So this is equal to, x is equal to how much? This is L. Ax is equal to 6g divided by 2 into its mentioned t naught square. So this implies t naught is coming out to be under root L divided by 3g. So now we can check the options. For ball to hit the top of the container at point at end Q, A naught should be 3g by 2. No, we are getting it's 2g, so it's matching with option B. And similarly, ball hit the top of the container at end Q after time t naught under root L by 3g, and that exactly matches with option C. So correct options for question 1 is B and C. So this is about problem number 1. And the next problem, okay, next question number 2. So in a radioactive decay process A decay to B, two graph of number of nuclei of A and B versus time is given. So here this is the number of nuclei of A versus time and B versus time, and here A is decaying to B, and it's also like from this graph I can write at t is equal to 0, it's only n naught, number of nuclei of B is 0, and finally later on time it's completely decaying to B. So this is what exactly happening, and at any time this is the, like I can write Na is equal to what? N naught into e raised to power minus lambda into t, if lambda is the decay constant of this process, and for different times it is given. So I can write at t is equal to 6 seconds, this is equal to n naught divided by how much? T is equal to 6 seconds, it's 8, and that's equal to n naught e raised to power minus lambda into t. Just simplifying it, n naught gets cancelled, and taking log this, we are getting t is equal to 6 seconds. So we are getting it's actually 6 lambda is equal to ln 8 and lambda is equal to ln 2 divided by 2. So this is what we are getting from this data. Another thing is that n naught by 5, this is at t1 time, this is mentioned as t1 time, equal to what? N naught e raised to a minus lambda into t1. We can simplify it again. So this is ln 5 is equal to what? Lambda into t1. So t1 is equal to what? Ln 5 divided by lambda, and lambda we are knowing it ln 2 by 2. So this is equal to 2 ln 5 divided by ln 2, and by base change theorem I can write this is equal to 2 log 5 base 2. So this is the value of t1. And the next thing, number of nuclei of n naught, finally it's becoming n naught, and at t2 time this is actually like nb is given as that, and I can write, so if nb at t2 time is this, then what will be na? Na can be written as basically n naught minus nb, right, and that is equal to n naught minus 9 n naught by 10, that is equal to n naught by 10. So this is the time t2, and that will be also for this case also. So this means I can write n naught by 10 is equal to what? N naught e raised to a minus lambda into t2. I hope you are understanding this relation. Simplifying it, n naught gets cancelled, ln 10 is equal to lambda t2, and t2 we are getting its ln 10 divided by lambda, that is equal to 2 divided by ln 2, right, and this can be further simplified. So t2 will be equal to what? This is ln can be written as 100 divided by 2, or ln 2, and this can be expressed as t2 is equal to ln 100, not ln, it's log 100 base 2. So we got few these things, we can check the answer. So t2 log 100 base 2, yes, that's matching, t1 also matching. So we got actually C and D, this matches with option C, this matches with option D, and let's get the t2 minus t1, or okay, so t2 minus t1, that will be like ln or log, this is 100 base 2 minus log, this is 5 base 2. Clear? and this can be written as, basically I can write this is equal to log 5 like 2. This 100 can be written as what, 5 multiplied by like I can write 4 multiplied by 25 minus log, this is 5 base 2, is it? And this will be equal to log 4 base 2 plus log 25 base 2 minus log 5 base 2. Clear? And this is equal to how much? It's actually like ln t1 is multiplied by 2 also, minus 2. So this is minus 2 and minus 2, right? I hope everyone clear up to here. This is equal to 2 power 2, and that can be written as simply 2 plus. This is log 25 can be written as 5 raised to power 2, so that can be written as 2 log 5 base 2 minus 2 log 5 base 2. Clear? And you can see now here this is simply getting cancelled. We are left with only 2. So this implies t2 minus t1 is coming out to be 2. So now we can check the options which is matching. So that is B, C and D. So answer for question number 2 is B, C and D. That is question number 2. Next, question number 3. Let's see. Okay, next question number 3. A non-uniform rope of length capital L placed on the ground, and rope is pulled by constant force F0 as shown in the diagram. There is no friction anywhere. Linear mass density of the rope is given by lambda x, which is also not constant. It's bearing lambda x is equal to lambda naught into bracket 1 plus x by L. Capital L, x is measured from the and B. If the tension at a distance x from the B is Tx, total mass of the rope is m, and acceleration of the rope is a0, then choose the correct option. So it's like, I think it's a easy problem. We can first, if this is the length, I can consider one small element of length dx, then I can write dm is equal to what, lambda x into dx. This is equal to lambda naught 1 plus x by capital L into dx. Integrating it, we will get total mass 0 to L, then I will get total mass m. So m is coming out to be lambda naught into, I am writing it directly substituting the limits. It's L plus L by 2. So this is coming out to 3 lambda naught into L by 2. That is the mass. And if I got mass, I know the force, then acceleration will be equal to a naught is equal to what? Force divided by mass, and that is coming out to be 2 f naught divided by 3 lambda naught into L. This is the acceleration. Is it? So if I consider one small element, let's say of length x, is it, then tension will be, I can write T is equal to its mass is, let's say, small m into a naught will be the tension. And what is the small m? So instead of substituting here limit from 0 to L, I can substitute the limit from 0 to x, then I will get the mass for corresponding that. So small m is equal to lambda naught into x plus x square by 2L. This is the small m, and T, tension, can be written as at distance x from and B, is it? So that can be written as simply m into a naught. A naught is constant, because that we are already getting. Let me substitute. T is coming out to be lambda naught x plus x square by 2 capital L multiplied by a naught. This a naught is equal to 2f naught divided by 3 lambda naught into L. This gets cancelled, and we are getting 2f naught divided by 3L. Then this is x plus x square by 2 times capital L. So we got tension. What else it is asking? So alright, it's asking about total tension. This is what we are getting, tension as function of L. Then I can write integral T dx 0 to L, then 2f naught divided by 3L integral x plus x square by 2L integral 0, dx 0 to L. So integrating it, it will be x square by 2, x cube by 3, and substituting the values, we are getting this value also 0 to L T dx or Tx dx. This is equal to 2f naught by 3L, and substituting 0, everything will be 0. This is L x square by L, so it's basically L square by 2 plus this is x cube by 3, so it's basically L square by 6, right? And this taking LCM divided by 6, so it will be like 3 plus 1, it will be 4 and 8 multiplied by, and simplifying it we will get In the numerator it will be like 4 into 2 8, and so 8 f naught divided into L square divided by its 2 also gone, so it will be like 9, then it should be 4. It should be 4 divided by 9 L, so 1 L will get cancelled, so this is 4, this is, so yes, that is also matching. M we already got, A naught we already got, and Tx yes we got, and we can see this is matching with option D, this is matching with option A, acceleration matching with option C, that's also correct. 2f naught by 3 lambda naught L naught, and mass M 3 lambda naught L by 2. So here we are getting all A, B, C, D, all are correct options, B, C into D, right? That is about problem number 3. Next question number 4. Question number 4. So a non-conducting uniform thin cell of mass m and radius r is having uniform charge density plus sigma one half and minus sigma on another half as shown in the figure. It is placed on rough non-conducting horizontal plane at t is equal to 0. A uniform electric field E is equal to E naught J cap Newton per coulomb is switched on and the solid sphere start rolling without slipping. Then which of the following statement is correct? So okay, so this is the diagram shown. The condition here we understood, uniform electric field switched on. Now let me understand, let me tell you what exactly is happening here. The thing is that this system can be treated just like hollow hemisphere having some charge magnitude q, and it's placed at the center of mass of hollow hemisphere, that will be like r by 2 from center, and similarly it's r by 2 from center. Magnitude of charge q can be written as charge density multiplied by area of hemisphere, that is 2 pi r square. So it's simply acting like a dipole. Then the dipole moment P can be written as P is equal to Q multiplied by the separation between two charges, that is equal to r by 2 plus r by 2, that is equal to r. So it's coming out to be sigma into 2 pi r cube. This is P and it will be directed in this direction. Electric field is mentioned, it's given in this way. It will be exactly like it's not appearing perpendicular, but it will be perpendicular to this line actually. Is it? Because so it will be perpendicular in this manner. So then if this is theta, this will be also theta, this will be 37 degree. Clear? Then we know actually tau due to electric field on a dipole is given by, this is equal to what? PE into sine of theta, where theta should be, this is the P and this is E, so the theta will be here 37 degree. So I can write this is equal to how much? 2 pi sigma r cube multiplied by E is E naught into, I'm directly writing PE magnitude, direction will be like inward, it will be, the sense will be clockwise of rotation, into sine of its 37 degree, right? So simplifying it, we are getting its 2 pi sigma r square into E naught into sine 37 degree will be equal to how much? This is simply 37 degrees, so it's 4 and like 3, 4 and 5, so it will be 3 by 5. So we got it up to here, it's 6 pi sigma r, it will be r cube into E naught divided by 5, and this is equal to how much? This is equal to I into alpha, right? I is what? Moment of inertia of hollow hemisphere, it will be. Okay, so up to here basically we understood this system is equivalent to like one dipole. Electric field, this we got the charge on one hemisphere that is acting like one pole, total dipole moment, and this is the torque due to the electric field. What is happening? This solid like hollow hemisphere is placed on rough surface, so because this torque is trying to rotate it clockwise, so this on this point the tendency will be to slide backward, so we can say the friction will be acting forward, right? And this is the torque due to only electric field, it's not the net torque. Now it is also given that uniform electric field switched on and the solid sphere start rolling without slipping actually. So this start rolling without slipping, what cell mass, something error is there actually. Non-conducting uniform thin cell of mass m and radius r is having uniform charge density, and in the last sentence it is saying switched on and the solid sphere start rolling without slipping. So it's not actually solid sphere. We will be considering it's like actually only spherical cell, hollow sphere. So in the last sentence it's saying solid sphere. That's not right actually. So now this is hollow hemisphere. So we got understood up to here. Friction. Then I can write actually for this system. First is torque due to electric field. It's like inward, and torque due to friction, so it will be minus F into R will be equal to I into alpha, or you can write ICM into alpha. Clear? And friction will be providing the required acceleration, that is you can write MA, and because condition is given for pure rolling, so I can write A must be equal to R alpha. Substituting it here, it will be MR alpha. Substituting it here, then it's tau electric field minus MR square alpha is equal to ICM is 2 by 3 MR square into alpha, and this implies we are getting tau E is equal to, taking it this side, it's 5 by 3 MR square into alpha, and this tau E is, we are getting it here, it's 6 pi sigma R cube into E naught divided by 5. Simplifying, we are getting alpha is equal to how much? R square R cube, so it's 6, it's 18 pi sigma R E naught divided by 5, 25 multiplied by m. This is the angular acceleration of this spherical cell. Right now, if it is doing pure rolling, then acceleration of center of mass will be there, and acceleration of total, this will be A plus R alpha, and we know A is equal to R alpha, so total acceleration will be 2A, right? So we understood up to here. Now we can check the acceleration of topmost point of the hollow sphere at t is equal to 0. So we can get that. Alpha we got, what is A? A is equal to R alpha, that is 18 pi sigma R square E naught divided by 25 m. This is the acceleration. Acceleration of topmost point A, topmost point, that can be written as A plus ACM plus R alpha, that is equal to 2 times ACM. This is equal to ACM, and this is equal to 2 multiplied with this 36 pi sigma R square E naught divided by 25 m, and that actually matches with option A. Magnitude of frictional force at t is equal to 0. So magnitude of frictional force is equal to what? M into A, and m we already have, and acceleration we already have, so then it can be written as, basically this is equal to 18 pi sigma R square E naught ACM, just, yeah, that's right, divided by 25 m multiplied, then gets cancelled. So this is the friction force acting on sphere at t is equal to 0. That actually matches. Acceleration of center of mass of the hollow sphere at t is equal to 0. Acceleration of center of mass we have already got, it's 18 pi sigma R square E naught by 25 m, so it's not actually matching. C option is not. Magnitude of frictional force, so no, it's basically, so this is matching with option B, and this acceleration of topmost point matches with option A. So the correct option for question number 4 is A and B. So this is the answer. Next question, question number 5. A point object is placed at 30 cm from a convex lens, mu g is also given, of focal length 20 cm. The final image of the object is formed at infinity. So this is question number 5. It's given convex lens, and mu g is given as 3 by 2. Its focal length is given as 20 cm. We know 1 by f is equal to mu g minus 1 into n. If it is equiconvex, then it can be written 2 by r. R is the radius of curvature of each surface. And if I substitute these things, then this implies r is actually coming out to be 20 cm. Okay, so this is up to here. Data, final image of the object is formed at infinity. So object is placed at here, and final image is formed at infinity. Its focal length is 20 cm. In this situation, it's not possible. We need to make some changes so that this 30 cm become actually the effective focal length of this system, 30 cm. Then only it's possible that final image is formed at infinity. So we need to check for the following options which can make the effective focal length of this lens equal to 30 cm. That will be our correct option. So another concave lens of 60 centimeters placed in contact with the previous lens, we will check the effective focal length. 1 by f is equal to 1 by 20 minus 1 by 60, and this is equal to 60 LCM, and this will be like 3 minus 1, it's coming out 2 by 60. This implies f is coming out with 30 centimeter. So yes, if we are placing another concave lens of 60 centimeter focal length, then the effective focal length of the system can become 30 centimeter, and in that situation, object placed at 30 centimeter, the final image will be formed at infinity. So A is actually our right option. Another convex lens of focal length 60 centimeters is placed at a distance of 30 centimeters from the first lens. So in this situation, the effective focal length can be written as 1 by f is equal to 1 by 20 plus 1 by 60 minus 30 divided by 20 multiplied by 60. We can check what is the effective focal length coming in this situation also. So this is how much, 0 gets cancelled, and this 20 60, it's 60, and it's 314 minus it's 1 by 40. Taking here it's 120, and this will be like 8 minus here this multiplied by 3, so it will be like 3. Then we are getting it actually 5. 120 divided by 5, that will be equal to 25 centimeters. So it's not matching. In this situation, the focal length, effective focal length, cannot be 30 centimeters. So it will not be. The whole system is immersed in a liquid of refractive index. So we can check for that option also. If lens is immersed in a liquid of refractive index some mu, then its focal length is given by its mu lens divided by mu medium minus 1 multiplied by 2 by r. We know everything actually, and substituting we check and we get actually C, it's not matches, and D, it comes exactly 30 centimeters. So our right options will be A and D in question number 5. So it's A and D. Check the answers. Next question, let me first erase. Okay, next question number 6. In the cylindrical region of radius r is equal to 2 meter, there exists a time varying magnetic field B such that dV by dt is equal to 2 Tesla per second. A charged particle having charge q is equal to 2 coulomb is placed at a point P at a distance of d. So this is point P, charge q is placed at a distance of d, small d, from the center, from center O. Okay, so center O is this. Now the particle is moved in the direction perpendicular to the line OP by an external agent up to infinity, so that there is no gain in kinetic energy. So this particle is moved by some external agent. External agent is moving it, so that delta K is equal to delta KE is equal to 0, means no change in kinetic energy is taking place. If capital D, D is greater than R, then which of the following option is R correct? Okay, so first, time varying magnetic field is there, so definitely there will be some electric field, and here you can see magnetic field is inward direction, right? So what will happen actually, EMF, and it's increasing, so the EMF will induce, or electric field will induce in a manner such that it will try to reduce. So by that I can write the electric field induced will be in this direction, and that can be written as integral E dot dl is equal to area into dB by dt, or we write it basically d phi by dt, that is equal to A into dB by dt. E will be equal to E dot dl. dl is equal to 2 pi into here the point is at this point. If I want electric field, then it will be E into 2 pi d, but I want the electric field because the particle will be moving along this perpendicular to this OP path. So if let's suppose from P point the particle has moved up to here, distance x, then what is the electric field at this point? So I want the electric field in terms of x. Then for this distance is equal to what? Under root x square plus d square. So I will write into, let's say this is a small r, so E dot dr 2 pi r, and this is equal to area. Area will be like, in this situation, if total magnetic flux is linked in this area also, then we need to write the complete area, but here flux is linked only in this, so we will write it, this is pi into r square into dV by dt, that's given as 2, so multiplied by 2. This is, so then we are getting E is equal to pi 2 pi r square divided by 2 pi multiplied divided by, this is what, that's okay, r square, this is x square plus d square. Solving it, we are getting it simply r square divided by under root x square plus d square. So this is electric field. Now electric force on this particle will be in this direction. So the external agent want to do some work, he need to apply some force exactly in opposite direction, so that things are getting cancelled out, is it? And net force, so this force due to external agent must be in this direction. So if this is theta, then this will be also theta, right? So then I can calculate dw, work done by external agent. If the particle is moving from here to there, this is equal to what? F dot dx. This will be work done, and F will be equal to what? QE, right? So this implies this is q r square divided by under root x square d square into dx dot dx. So this is q dx into cos of theta. This, and x is equal to from 0 to infinity. It's mentioned it's moving from 0 to infinity, and 0 to total work w. So w integrating, let's simplify it. So it's q r square into, this is all constant, dx. Cos theta will be equal to what? Cos theta is equal to d divided by r. So it's basically d divided by, this is under root x square plus d square multiplied by 1 by under root x square plus d square into dx. Simplifying it, so this is q r square d integral dx divided by x square plus d square, integral 0 to infinity. So then integration of this comes out to be basically q r square d divided by d into tan inverse x by d, and substituting the limit 0 to infinity, 0 tan inverse 0, I mean like 0, it's all 0, infinity, so tan inverse infinity, that will be pi by 2. So then I'm getting its w, we are getting it's equal to q r square d gets cancelled into pi by 2. This is what expression we are getting. Let me substitute the values, then we will get work done is equal to q is 2 coulomb, r square it's like 4 into pi is pi, I did something mistake, I think. Okay, it's all right up to here, let's check. So this divided by 2, so then 2 gets cancelled, so we are getting w is equal to 4 pi joule, right? Let's check the options now. Okay, so here now work done by external agent is 4 pi joule when d is equal to 4 meters. So first thing is, you can check here, work done is actually not depending on the value of small d, is it? And work done is equal to 4 pi, it's constant. So work done by external agent is 4 pi joule when d is equal to 4 meter. It's actually right answer. Work done by external agent is 4 pi joule when d is equal to 8 meter, because it's not depending on d, so that is also correct. Work done by external agent is independent of d, this is also right. Work done by external agent is positive, and that we can see this is also positive. So all A, B, C and D options are correct. Next question number, this is question number 6. Next we have passage based. Let me first erase this question. Okay, next question number 7 and 8, it's passage based question. So paragraph for question number 7 and 8, let me read it first. Uniform wire frame of linear mass density lambda having 3 sides each of length 2a is kept on the smooth horizontal surface. An impulse j is applied at one end as shown in the figure. P is the midpoint of the line AB. Angular velocity of system just after the impulse. Question is simple actually here, like we just need to consider like angular momentum conservation. For that we need to first calculate center of mass and its moment of inertia of the system about center of mass. So this is mass, just simplifying, we will get center of mass here at a distance. This is the center of these rods, so this distance will be a by 3. This we can get under root a square plus is a by 9 whole square, so that will be actually under root, this is 10a by 9. Okay, so let me first write total ICM. If its mass is m, then m length is 2a whole square divided by 12 ICM plus m into distance, this is 2a by 3 whole square. So this is the moment of inertia of this rod AB. This then plus moment of inertia of this one of the rod is m, first m into 2a by 12, 2a square divided by 12 plus m into md square. So d square is 10a square divided by, this will be a outside, so 10a square by 9. This is this, and same for this rod, so multiplying by 2. You can simplify it actually and you will get it's 22. This is substituting the value of m, also 22 lambda a cube divided by 3 will be the ICM, moment of inertia of this system about center of mass. Then for question number 7, it's saying impulse J is imparted at like this. So I can write conservation of angular momentum, or I can write basically impulse momentum theorem. Then impulse momentum theorem, so what it implies, angular impulse JA is equal to initial angular momentum 0, final is ICM into omega, J into A, ICM how much we got, 22 lambda A cube divided by 3 multiplied by omega. Simplifying it, we are getting omega is equal to 3J divided by 22 lambda A square. So this will be the angular velocity of system or this wireframe just after the impulse is imparted. Next question number 8. The velocity of point P just after the impulse is. So point P, velocity of point P. So we got, this is the angular velocity. What will be the linear velocity of center of mass? Linear velocity of COM. So this can be written as G is equal to 3m, and like total mass is equal to, let me write total mass, that will be like 3 multiplied by mass of rod 2a lambda multiplied by, so this is the total mass multiplied by VCM. So we are getting VCM is equal to J divided by 6 lambda A. This is the velocity of center of mass. Then it can be expressed VP is equal to VCM, and it will be in vertically upward direction. So you can write J cap plus angular velocity is in this direction, so R, basically this distance multiplied by omega will be the, so we can write omega into 2a by 3, this will be I cap. So velocity, simplifying, we will get VCM J by 6 lambda A J cap plus omega is omega how much, 3j divided by 22 lambda A square multiplied by 2a by 3 I cap. So this is 3j gets cancelled, a gets cancelled, 22, so it's J by 6 lambda A J cap plus this is J divided by 11 lambda A I cap, and here we can write J by lambda A can be taken out, it's basically 1 by 11 I cap plus 1 by 6 J cap. So any option matches with this, that's option D. So this is the answer for question 8, and answer for question number 7 matches 3J by 22 lambda A square, that's matches with option A. So this is about passage paragraph for question number 7 to 8. Okay, so next passage for question number 9 and 10. Consider YDSE arrangement as shown. The screen in the arrangement start accelerating from rest in the positive x direction at with acceleration a given by k into t, where k is some positive constant, t is the time, and at t is equal to 0, this is the position of the screen, that is equal to d. Now based on this, it's asking rate of change of fringe width R for a fringe pattern on the screen varies with time as. So rate of change of fringe width. So first, what is fringe width? Fringe width is equal to lambda capital D by small d. So capital D, t is equal to 0, this is the capital D, but I will write let's say d prime. So then d prime at any time is equal to what? Capital D plus whatever the distance this screen is moving. So here acceleration is given as function of time, so velocity can be written as what? Kt square by 2, this is the velocity. substituting because t is equal to 0, it's starting from rest. Then x displacement is equal to what? It's k t cube by 6. So d prime can be written as d plus x. Clear? So then beta is equal to lambda d plus x divided by small d. Now it's asking the rate of change of r versus like this beta here, it's taken as r. So rate of change of this fringe width, okay, wait, this, then rate of change of fringe width with respect to time is taken as r, and that versus time it's asking. So let me substitute here values. Lambda capital D plus x is equal to how much? K t cube by 6 divided by small d. Then what is d beta by dt? That is the rate, and differentiating it will come out to be lambda capital K 3, then it's like t square divided by 2d. This is our, so you can see it's a parabolic graph. T is equal to 0, it will be starting from 0, and it will be like increasing maxima. So that option here, if you just plot, it's like a parabolic curve, it will be simply matching with this. So this is r versus t, that option matches with like answer matches with option C. Next, question number 10. Velocity of nth maxima above O at any time t in the ground frame. So let me first find position of nth maxima, then rate of change of position of nth maxima will be its velocity. So we write d sine theta is equal to what? N lambda for nth maxima. Sine theta dy by capital D is equal to n lambda, and y is equal to n lambda capital D by small d. Right? And capital D, again, because it's changing with time, so I will be writing it better d prime, and this is equal to n lambda by small d, it's capital D plus what? X. So y is equal to n lambda divided by one more thing, because here screen is also moving, so it's let me first get its y coordinate. It will have some x velocity also. X velocity will be simply equal to the velocity of screen. So this is n lambda divided by small d into capital D plus x is equal to how much? It's k t cube by 6. Then let me get its vy. Vy is equal to dy by dt, and that comes out to be n lambda by d, and differentiating it, it will come out to be k t square by 2. So this is vy. What is vx? Vx is equal to this velocity, that is k t square by 2. So then net velocity will be simply v is equal to vx I cap plus vy j cap, and we can check the option. So kt square by 2 is coming basically common this, so that will be kt square by 2, it's I cap plus n lambda by small d, it should be j cap, that should be the, so here I cap plus n lambda cap divided by small d into j cap, that actually matches with option A. So this is the velocity of nth maxima above O at any time t in the ground frame. This is about your passage 2. Okay, so next is numerical value type questions. Question number 1. So in a radioactive decay, A is getting converted into B and B is getting converted into C. So this is a successive radioactive disintegration. We have studied this in lecture, and so on this it is given that at t is equal to 0 nuclei of B and C are not present. So at t equal to 0 it's given only n naught, 0 and 0, and then at some time there will be like nb and nc. The decay constant for A to B is lambda 1, decay constant for B to C, so it's lambda 1 and lambda 2. Lambda 1 is given as 5 lambda, and the value of lambda 2 is given as 2 lambda. The time after which B will have maximum number of nuclei is of the form of this, then the value of B naught will be. So number of nuclei of B at any time t, we can get the expressions. This is a like standard formula, we can use directly that too also, otherwise it will be like little lengthy process, you need to go for integration and derive it. So I'm using it, it comes out to be lambda 1 by into n naught divided by lambda 2 minus lambda 1 and multiplied by e raised to power minus lambda 1 into t minus e raised to power lambda 2 into t. So this is the number of nuclei of B at time t. Then it's talking about maximum, so we can differentiate d and b by dt should be equal to 0. This is a constant, simply we can take it. So this differentiation of this, it's e raised to power minus lambda 1 into t into lambda 1 plus lambda 2 e raised to power minus lambda 2 into t. This should be equal to 0. This constant term here, lambda 1 and naught, divided by lambda 2 minus lambda 1, that cannot be equal to 0. So this cannot be equal to 0, then only this will be equal to 0. We can make it equal to 0. So this implies it's basically lambda 1 e raised to power minus lambda 1 into t equal to lambda 2 e raised to power minus lambda 2 into t. And it's okay, then I can take it this side, so it will be equal to how much? It can be written as e raised to power lambda 1 minus lambda 2 into t equal to lambda 1 by lambda 2. It can be rearranged in this form, and then taking log ln this, we are getting actually t is equal to ln lambda 1 by lambda 2 divided by lambda 1 minus lambda 2. This will be the time. Let me substitute the values now. So substituting the value, we are getting t is equal to ln lambda 2, lambda 1 is 5 lambda, it's 2 lambda divided by 5 lambda minus 2 lambda. So t we are getting ln 5 by 2 into 3 lambda. And then just wait, let me check it if we have done all right. So, and lambda 1, lambda 2, 5 lambda, 3 lambda, yes, that's correct. So this implies divided by, so 2 b naught is equal to 3. This implies b naught is equal to 3 by 2. So b naught is equal to 1.5. This is the answer for question number 1. Next, question number 2. So a system of two plank and sphere of radius capital R is in motion as shown in the figure. So this is a sphere, this is one plank, and there is another plank in this manner, and it's like alpha and acceleration a. Acceleration of this plank is given as a1 and acceleration of this is given as a0. This is the situation given to us. So radius of this sphere is capital R. There is no slipping anywhere, no slipping anywhere, and it is given that. So what else? First thing is no slipping anywhere condition, and it's given as R alpha is equal to 2 a0, and where alpha is the angular acceleration of the sphere and acceleration of the upper block is a1. A1 is given as k a0, and where k is a positive constant, then the value of k, so the value of k is supposed to be find. So this is the problem. We can write the condition and apply this condition for no slipping at all points. So if this is the situation, then about, let's say this is point P and this is point Q, so no slipping at Q, that means a0 should be equal to what? A minus R alpha, and it's given as R alpha is equal to 2 a0. This implies A is equal to 3 a0. So we got one condition. Now similarly, no slipping at P, then I will get basically it's acceleration of net acceleration of this point will be A plus R alpha. So I can write A plus R alpha should be equal to A1. A I already got 3 a0. R alpha it's already given as 2 a0. 2 a0 equal to A1. This implies A1 is equal to 5 a0, and it's given A1 is equal to what? 2 like k a0. So comparing this with this implies k is coming out to be the 5. So this is the answer for question number 2. Next, let's see. Okay, so next question number 3. An infinite uniform current carrying wire is kept along z-axis. So this is the wire kept along x-axis, carrying current I0 outward in the direction of the positive x-axis, and O, A, B, C, D, E, F, G represent a circle where all the points are equally spaced, whose center at point 4 meter, 0 meter and radius 4 meter as shown in the figure. Then integral B dot dl over def is given as mu naught I naught k divided by 2, where in SI unit then the value of the k. So this is the question actually. So what we can do is we need to find the integral B dot dl is equal to like mu naught I naught into k divided by 2 over this space only. The simplest case to solve this situation is we can consider one circle like this. So now integral b dot dl over this will be equal to b dot dl over this, and where this is radius, so we can actually write this angle will be like 45 degree, is it? Because sorry, this radius and this radius, so this will be 45 degree, means pi by 4. And then for this circle I can write integral b dot dl for complete reason. I can write it's mu naught into I enclose I naught. Then mu def is equal to, let's say this is O prime and let's say this is H. So integral b dot dl over def will be equal to integral b dot dl over only this is O prime into H, right? And this is equal to what? For complete I can write this, then this is what? I can write this is equal to mu naught into I naught divided by 2 pi for complete. This is per unit angle multiplied by this angle is pi by 4. So we are getting it's mu naught I naught into divided by 8 is the answer. This is this equal to this. Now comparing these two, we are getting k value is equal to 1 by 4, that is 0.25. This is the answer for question number 3. Next question number 4. So a closed organ pipe of length L and an open organ pipe contain gases of density. So we have like two. One is closed organ pipe, this is closed, length L, density rho 1. Another is open organ pipe, let's say length L prime, density of rho 2 is filled in the gas of density rho 2 is filled. Respectively, the compressibility of the gases are equal, and let's say compressibility K and compressibility K. Both the pipe are vibrating in their first overtone. So the frequency for first overtone in case of closed can be written as 3 by 4 L, and its speed, let's say V1, that's all. And what is V1? V1 can be written as 1 by K into rho 1. Similarly, V2 will be written as 1 by K into rho 2, because K is the compressibility which is given as constant or same for both the pipes. So this we got, let's say F1 and first overtone. Similarly, F1 for this will be 2 divided by 2 L prime. Its length is L prime into V2 and V2. So now just these two frequencies are equal, it's clearly mentioned. So then F1 equal to F2, this is equal to 3 by 4 L, and V can be written as 1 by under root K into rho 1 equal to 1 by L prime under this is 1 by under root K into rho 2. Under root K cancel, we need L prime, so L prime is equal to what? 4 by 3L multiplied by how much? It's rho 1 by rho 2 under root power half. So then this implies L prime, and comparing it with the K L rho 1 by rho 2 into power half, we are getting simply K is coming out to be 4 by 3, that is 1.33. This is the answer for question number 4. Similarly, next question number 5. Next question number 5. So here it's given as a non-conducting thin disc of radius r charged uniformly over one side, rotated uniformly with an angular speed omega. This omega about an axis passing through its periphery and point P. So this is the axis passing through periphery at point P and perpendicular to its plane. The electrostatic potential at point P due to the charge on the disc is given as, so potential of point P is given as V naught, and the magnetic field at point P due to the moving charge upon rotation is, so B point P is given as 2K mu naught epsilon naught omega multiplied by V naught. This is, and then we are asked to find the value of K. So this is the question. So if I take one small like this sort of part of the disk at a distance r, then charge can be written as dq, then potential dV due to this charge at point P can be written as K dq divided by r, and this is 1 by 4 pi epsilon naught into dq by r. Integral this will be equal to V naught, integrating it to complete disk. So we got dq and this is the like value V naught. Next thing is if dq is this charge and it's rotating with angular speed omega, then current corresponding to current due to rotating dq charge, that can be written as di is equal to what? Dq divided by time period, that is 2 pi into omega. If this is di, then what is the magnetic field due to this di at this? It will be acting like one ring, is it? So dB can be written as, it's like mu naught into di divided by 2r, right? Substituting mu naught into di can be written as dq into omega divided by 2 pi into 2r. So it's mu naught into omega divided by 4 pi integral dq by r will be your total dB integral, and that we can get b naught, is it? So this implies b naught is equal to what? Mu naught omega 4 pi and integral dq by r is equal to what? 4 pi epsilon naught into v naught. So integral dq by r, so we know this value is equal to mu naught omega by 4 pi, then this value is equal to, from here I can write integral dq by r is equal to 4 pi epsilon naught into v naught. So substituting this value here, then it's 4 pi epsilon naught into v naught. 4 pi gets cancelled, so we are getting it's mu naught epsilon naught into omega into v naught. So we are getting, that is the magnetic field at point B. So now comparing this and this implies 2k is equal to 1 and k is equal to 0.5. This is the answer to problem number 5. Okay, next question number 6. Uniform solid cylinder of mass m rests on two horizontal plank. The thread is wound on the cylinder. The hanging end of the thread is pulled vertically down with a constant force F, which still does not bring any sliding of this cylinder. If the coefficient of friction between the cylinder and the plank is equal to the mu, what is the maximum acceleration A max of the axis of the cylinder rolling over the plank? And this is all given. So if you look at it, this diagram from front side, then it will be like this is the cylinder. Let's say the normal reaction due to both the planks is given as n, and due to this force it will have like rotating this, so this point will have sliding tendency forward, so that the friction due to both the planks is equal to F. I am taking F and N as net normal and net friction force, and mg will be acting downward. So this is all situation now, and it's let's say this will be the alpha, and acceleration of center of mass is A. Then we can write a simple equation for this. So this implies N is equal to what? Mg plus this force, and F is equal to what? Ma, equation 1, equation 2. And next for torque, so this is F into R minus torque due to friction is equal to I mr square by 2 into alpha. And for no sliding, A should be equal to R alpha, is it? So we understood it here. So from here we are getting this, let's say equation number 3, equation number 4. F is equal to this Ma, and A I am getting here equal to F by M, and that should be, from here I can get 1 R gets cancelled and R alpha is equal to A, and then this is coming out to be F minus F. So this is capital F minus F divided by what? Divided by capital F minus F divided by M by 2 is equal to also A. Simplifying it, mm gets cancelled, this is 2, so F is equal to 2F minus 2F. This implies F is equal to 2 capital F by 3. We got one relation, and this is equal to how much? Ma, right? So substituting these values, and we know friction is equal to what? Mu times normal reaction, clear? And normal reaction is given as this. So just substituting the values, we understood it here, and F we got value, friction we got. We are asked to find the maximum value of A, so we just need to get the value of capital F in terms of mg. So okay, small f is equal to mu times normal reaction is equal to mg plus this is f, right? And small this is given to 3f by 2, so 2f by 3. 2f by 3 is equal to, this is 1 by 3 into mg plus f. 3 gets cancelled, so this is 2f is equal to mg plus f. This implies f is equal to mg. Clear? So we got f is equal to mg. Then I can substitute here equal to ma. So ma is equal to 2f by 3 equal to, this is f, and f is equal to mg. So ma is equal to 2 into mg divided by 3. Gets cancelled, a is coming out to be 2g by 3, that is 6.6767 meter per second square. This is the maximum acceleration of cylinder for not sliding condition. Okay, next question number 7. The capacitor of capacity 6 microfarad, C is equal to 6 microfarad, and initial charge Q initial is given as 160 microcoulomb, is connected with the key S and resistance as shown in the figure. So this is the key S and resistance shown in figure. Point M is asked. This is point M, which is grounded. T is equal to 0. The current through the resistance R is equal to 1 ohm. So through this current is, let's say, I1. That is what it is. And if the key is closed at t equal to 0, and current through resistance R equal to 1 ohm at t is equal to 16 microsecond will be. So that is what we need to find. So first thing is this system, simply these two resistors in series and these two in parallel can be written as this way. So R equivalent and C. So tau equal to RC, that comes out to be 8 by 3 multiplied by 6, that is equal to 16 microsecond. And that is tau. Then Q can be written as basically Q naught into e raised to power minus t by tau, right? And I is equal to dq by dt, Q naught, and this is equal to Q naught by RC e raised to power minus t by tau. We just need to find the magnitude. So I am writing minus sign. I'm just simply, you can write writing the magnitude. Total current flowing through this I, total current. Is it just substituting the value? Q is 160 micro and RC is 16 micro, and e raised to power minus t is equal to 1 second. T is 16 microsecond. So 16, and RC is also given as 16 micro. So this is equal to simply 1, and we are getting it 16. It's basically 10 ampere, and because this is micro it's cancelled, so I is equal to 10 into e raised to power minus 1, right? This is the total current flowing through this battery. Then current passing in this arm will be like inversely proportional to resistance. So your resistance is low, the current will be high. Resistance is high, the current will be low. So I can write I through 1 ohm will be equal to 2 by 3 of I naught. Let me write, it's equal to I naught. So this is equal to 2 by 3 multiplied by 10 e raised to power minus 1, and then I through 1 ohm is equal to 20 divided by 3e, and substituting the e is equal to 2.7, we are getting I through 1 ohm is equal to 20 divided by 3 into 2.7, simplifying it we get 2.46 ampere. This is the answer to question number 7. And the next one, last. Okay, so next question number 8. The distance between the parallel plates of an isolated charged condenser is d, that is given to 5 centimeter, and the intensity of electric field between these plates is given as this 300 volt per centimeter. And a slab of dielectric constant K is equal to 5 and d thickness T is equal to 1 centimeter is inserted. Wide is inserted between the parallel to the plate. Determine the potential difference in volt between the plates after the slab is inserted. So first thing is if I take area, then I can write C naught is equal to A epsilon naught divided by D. Is it? And D is given as 5 centimeters, so it can be written A epsilon naught 0.05. This is C naught. C will be equal to what? A epsilon naught divided by D minus T plus T by K. So let me just check how much my C has become. So it's A epsilon naught divided by D is again 0.5 minus 0.01 plus 0.01 divided by K is equal to 5, right? Then we can simplify it. So C is equal to This is A epsilon naught divided by 0.04 plus 0.01 divided by 5, multiplying it. This is 5 multiplied by A epsilon naught. This multiplied by here, so 20, so it's like 0.21, and this is A epsilon naught can be written as from here. A epsilon naught is equal to what? C naught into 0.05. So it's 5 multiplied by 0.05 into C naught divided by C naught. This is divided by 0.21. Point decimal gone, 25 by 21. So C, we are getting 25 by 21 C naught. So the capacitance of the system has increased, is it? And it's talking about the determine the potential difference. So first thing is, because it's isolated capacitor, so here the total charge Q initial will be equal to Q final, and this can be written as C into V. C naught V naught is equal to C into V. Q is equal to CV. C naught potential is like 300 divided by 5, right? And final is 25 C naught divided by 21 multiplied by final potential, let's say some V. And simplifying it, C naught gets cancelled, and we are getting V is equal to 300 divided by into 21 divided by 5 multiplied by 25, right? Simplifying it, we get V is equal to some 1260 volt, and this is the answer to this problem. So this is all about basically your paper one for FST 24. I hope you should be understanding, all the queries should be clear and all the questions must be clear to you, whatever the doubt you were facing. So this is all about. Thank you so much.